Hey YouTube, today we have this problem, climbing stairs. You climbing a stairs, it takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can we climb? Can you climb to the top? So basically, if we have, let's look at the example so we could understand the problem. If we have only two stairs, there's only 2 possible ways. So 1 1 or 2. If we have n equals 3, so basically all of those possibilities will be 1 1 1 or 1 2 or 2 1. So how we can put this in code? Let's just go to the sketch so we can understand everything better. So let's say that I have 5. How many basically ways to go to 5? Basically it's let's take 4 because I guess 4 it's easier. How many? We have 4. How many ways can we get to 4? So basically we have 1 1 1 1 1 2 1 or 2 2 or 2 1 1 or 1 1 2, and yeah, that's it. It's only there is 5 ways to go to number 4 basically. And we can do the same with number 5, number 6, and I guess it will take bigger with time. And basically the way that we can solve this problem is maybe there is a lot of different ways. We can do recursion, we can do dynamic programming, we can do we can just loop through each possible solution and just keep tracking of it. But for this time I'd like to use something called the Fibonacci sequence. So let's just talk about how a Fibonacci sequence looks like. So let's just delete that and let's go back with this one. Let's say I have number 1, number 2, number 3, and number 4. And basically we are at number 0 here. Okay, so what is the possible ways to go from 0 to 1? Only one step that we can go. Okay, how many steps that we can go from 0 to 2? We can go to 2 by there's 2 steps. We can go by 1 1 or 2 directly. So basically we have let's just put this in different so we have okay, so basically the way that we can go from 1 to from 0 to 1 is 1. Going from 0 to 2 we have only 2 solutions. Like we can go from 2 directly, we can jump 2 times directly, or we could go 1 1. How many times we can go to 3? Yes, it's only 3 ways. How? It's basically we can go from 1 1 1 or 2 1 or 1 2. This is all the possible ways. How many times we can go to 4? If you remember, we said that there's 5 times we can go to 4. However, if you looked at the last two steps, how each number of them, how steps equals, you find if we add both of them, it will equals 5, which is here. So if we added the same that we added like 5, how many steps that we can go to 5? Yes, that's right. We have 3 plus 5, it will equals 8. You can try by yourself, try by each possible. You have only 8 steps. So instead of calculating each number, we can only get the sequence of the last 2 digits basically. And I will tell you something, it's how we code this one. It will be really easy actually. It's one of the easiest algorithms to code actually. So basically let's just give it a look. So how we can approach this one? For first, I'll just make a simple check. If n equals 1, return 1. I will say also if n yeah, let's say that if n equals 1, I will maybe like create an array called db, for example. Okay, and it will be new array of n plus 1, because we don't want to count the 0. And I will say db of 1 equals 1, db of 2 equals 2, because we know both of them, and I guess we don't have to loop all of them. So I will say I'll make a for loop, and let I equals 0, I less than no, it will be I equals 3 basically, because we skipped the first two numbers, because we actually have the values. I less than or equal n I plus plus, and let's just have the function. I would say db of I will equals, as we said, db of I minus 1 plus db of I minus 2, and I will return db of n. Let's see. Well, not db I, db, just db, not db I. And yeah, at some complexity of this one, it's of n, and yeah, that's it for this problem. It's only 42%, but however, we could go with better solutions, dynamic programming. We can go with other fancy solutions, but because I didn't use Fibonacci before, I wanted to use it. I will share my my solution with you, and yeah, that's it for today. See you in the next problem.